Welcome to this custom-tailored deep dive where we are extracting the essential nuggets from a massive HDTV supply product catalog. Today, our mission is understanding a really specific piece of AV tech for you.
Yeah, we're looking at the DVIGear DVI-7313-TX, which is a 4K fiber optic transmitter.
Right, so to set the stage here, try running a standard HDMI cable across, say, a sprawling sports bar. You're going to hit a wall, literally and physically, you know?
Absolutely. Standard copper cables tap out after just a few dozen feet. After that, the video signal degrades into this total pixelated mess.
So how do system designers send flawless 4K video across massive retail locations without a drop in quality? Well, the answer involves shooting literal light pulses over extreme distances.
Yeah, to understand why this $349 device even exists, you really have to look at the physical limits of traditional wiring. I mean, copper wire is the industry standard for a reason, but...
But copper has electrical resistance, right?
Exactly. The further an electrical signal travels, the weaker it gets.
Okay, let's unpack this. It's kind of like a leaky garden hose. The longer that hose is stretched across your yard, the more water pressure you lose.
That's a great way to put it. By the time the water actually reaches the nozzle, you just get a trickle.
Yeah, so how does this DVIGear transmitter actually fix that pressure loss?
Well, by abandoning electricity altogether. It basically takes your standard HDMI or DVI signal and converts it into pure pulses of light.
Oh, wow, light.
Right, because photons don't encounter electrical resistance the way electrons do. So they just travel down a fiber optic tube virtually unimpeded.
Which is wild to think about.
It really is. And this unit pushes a 4K resolution image, so that's 4096 by 2160 pixels at 30 frames per second, over a single strand of multi-mode fiber optic cable.
And how far can it go?
Up to 1,640 feet.
Wait, really? 1,640 feet is over a quarter mile. But looking at the specs closely, there's a detail we should probably mention.
The HDCP limitation.
Yeah. It says it transmits non-HDCP HDMI version 1.4 signals. If it doesn't support high bandwidth digital content protection, I mean, you can't play protected content. So a sports bar couldn't actually use this to show a pay-per-view fight from a standard cable box, right? What's the catch here?
Right, that is a vital catch. Without HDCP support, this specific model will not play copy-protected consumer media like Netflix or Blu-rays.
So what is it actually for then?
It's built strictly for non-protected commercial applications. So think airport flight boards, massive digital signage, or maybe custom PC-driven video walls.
Okay, that makes sense.
And it uses multi-mode fiber, which basically bounces the light rays at multiple angles inside the cable to carry heavy data loads over those medium to long distances.
Got it. And what if a quarter mile of digital signage just isn't enough distance for your setup?
Well, then you'd step up to its sibling, which is the DVI-7314.
And what does that one do differently?
That model uses single-mode fiber, so it shoots a single, highly focused beam of light straight down the core to push the signal up to 1.2 miles.
Over a mile. Okay, so sending light over a mile obviously solves the signal loss problem. But I have a practical question here.
Sure. What's that?
Sending light is one thing, but how do the TV and the video player stay synced up when they are over 1,000 feet apart? Like, how does the video source even know what kind of monitor is sitting a quarter mile away?
Yeah, that extreme distance really creates a massive communication hurdle. Source devices and displays need to shake hands using EDID.
Extended display identification data, right.
Exactly. Essentially, the monitor tells the player its exact resolution and frame rate requirements.
But over a quarter mile, that digital handshake could easily fail.
Right. And to prevent that, this transmitter features what they call internal EDID memory and a dedicated Learn EDID button.
Wait, are you saying it memorizes the monitor's profile before you even run the long cable?
That's exactly how it works. You physically plug the transmitter directly into the display first, you hit the button, and it acquires and stores that specific monitor's data.
Oh, so then you move the transmitter a mile away back to the video source.
Yeah. Yep. And because of that stored memory, the video player just assumes the TV is plugged in right next to it. It ensures the system doesn't get confused by the extreme distance.
Tricking the source device is pretty clever. But what about the physical setup?
You mean the cables themselves?
Yeah, I mean, fiber optic glass sounds incredibly fragile. Is relying on glass strands for a rough commercial build-out asking for trouble?
You know, it's a really common assumption, but commercial fiber cables are heavily jacketed and remarkably tough.
So they can take a beating.
Absolutely. Reliability is really the main reason commercial integrators buy these from HDTVSupply. Yeah. Plus, they back the unit with a 3-year DVIGear warranty.
And free U.S. shipping, which is a nice bonus.
Yeah, it really guarantees that peace of mind for the installers.
We actually have a real user review highlighting that exact reliability. A customer named Victoria out in LA bought several of these point-to-point transmitters for her retail locations.
Oh, nice. What did she say about them?
She pointed out that once they're installed, they are incredibly stable and super easy for the floor staff to use daily across multiple stores.
Which is critical when your employees don't have IT degrees, you know?
Exactly. You don't want retail staff troubleshooting a fiber network.
No, you definitely don't. It really takes the complexities of high-end optical engineering and just boils them down to a system that works seamlessly behind the scenes.
Which I think transforms these dense AV catalog specs into a really clear picture of why this tech is so valuable.
Yeah, light is really revolutionizing commercial video setups.
It really is. But it leaves you with a final interesting question to ponder. If businesses are already converting standard video into light pulses just to span a single retail building— wait, let me rephrase. If they're going to these lengths right now, how long will it be until fiber optics fully replace the traditional bulky copper wires hiding inside the walls of our own homes?
That is a great question to leave on.
Thanks for joining us on this deep dive.